Let's have a look at the launch control then. How we can basically get the car off the line as quick as possible with the Syvecs range of ECUs and maximise the acceleration. Now, in order to get the best out of your car, there's two things which are really useful to have. If you've got a four-wheel drive basically car, a really useful tool to have is GPS. We sell a 50 Hz GPS module, which basically allows you to plot your then GPS speed as like your reference ground speed, so to speak, or vehicle speed, so that your traction control and launch control is then based off that. So that if you were to spin the wheels, etc., you'll be able to then see what your actual acceleration rate based on the GPS is versus your wheel speeds, and then hone in torque controls in order to basically maximize the acceleration angle of the tire. If you don't have that, another way you can do it is by using hold timers on basically a time-based system, or you can use it on a vehicle speed based if you have a good vehicle speed reference, i.e. if you're not spinning the front wheels or spinning the rear wheels if you are front wheel drive, or you're not even lifting the front wheels. We have a lot of ECUs on drag cars. The front wheels are off the ground for the first kind of 60 foot. So at that point, a GPS is obviously needed. So, or you can do it based on time-based, which is a really old school used method of doing launch control. So what we're actually going to do is actually going to set this one up based on the hold timer. Don't have a GPS on this, and this particular car does have a habit of spinning the front wheels and even lifting the front wheels. This is a twin-turbo Hurricane, which I'm currently in. So let's go through the launch control area and explain some of the tables and how we can do to maximize what we want from the car. So enable obvious launch control switch. The launch control switch on this particular car is the brake pedal. So you can see here, if I double click on launch switch, you can see it's turning on and off. Now, one thing to remember, a lot of the cars that are DSG control, if you were to be on the brake and on the accelerator and you're not in the correct launch mode sequence from the car, when you do that, you'll see the limp switch comes on here and it limits the throttle. Really key that is that you don't turn that off, because basically if you're in gear at that point and trying to go and launch the car, if the gearbox is not in the correct mode with the clutch open, then you'll burn the clutch. So don't turn those limp switches off and unassign it if you're basically wanting to do it. The only time that basically I would say if you need to unassign it in the pin assignments is if you're wanting to set the rev limiter up, the launch RPM up in a stationary thing in neutral, so that you wanted to get the RPM to basically hold its target, hold its target so that you don't limit the drive-by-wire. There's another way you can do that as well. Under drive-by-wire, you can raise your limp mode limit. You can raise the target from, like, say, 10% here up to 100 to allow you to open the throttle, and then like to play with your fuel cut severities, ignition cut severities, in order to hold the RPM at the set target. So what you want to do then, so the polarity and pull-up are irrelevant here. Launch hold timer. So this is the amount of time that we're going to have the timer active for. 1.4 seconds. Then you've got a minimum pedal position for activation. So when the pedal is above 10%, the launch control strategy then all becomes enabled if they're on the switch is on. You can disable the not control during launch. Might want to do it if you're doing ignition cuts. Can cause cylinder explosions in the exhaust, which can sometimes create noise on the knock sensors. Maximum vehicle speed for the activation. So the vehicle speed has to be below this value in order to activate the launch control. Then what you've got is a launch ramp mode. So basically, like I said, if you've got a GPS sensor, put the GPS sensor on it, then assign the GPS to vehicle speed and set your ramp mode versus vehicle speed then. If you haven't, the hold timer is a nice easy way of doing it if you have got the a setup which will lightly spin the vehicle speed if launching. So do it on a hold timer, and then you can change the brake points here, etc. Before we get to the base engine speed and the target manifold pressure, then we're going to look at the fuel cut severity. So basically, when you're staging, when you're using the hold timer, when the car is stationary, okay, basically the staged torque reduction values are here. So when the hold time is more than 0.10 seconds, or the vehicle speed is more than 3.3, then it will exit the stage state, okay? So that's only if you're using the hold timer. If you're not using, if the hold timer is at 0, then it will use these fuel cut severity, ignition cut severities in order to maintain the RPM and bring the boost up. But for the time being, we're using the launch hold timer. So the stage, so basically when the car is stationary, it uses these fuel cut severity tables. So the top axis, you've got your launch RPM error. So if you were setting the RPM for launch at 3,000 and it was at, say, 3,250, then the ECU will be applying a 25% fuel cut to that in order to control the RPM. If the manifold pressure error, the manifold pressure target error is 500 millibar over. If it's not, which it will start off being, then it won't be applying any fuel cut, because all that's done is it's done on ignition retard mainly to basically help the car. So you can see here where the manifold pressure target error is negative. When you've got error values, you can see here 42. So basically, if we're 250 RPM over the target, but the manifold pressure is not increased, then it will be using 42 degrees of ignition retard. That holds the RPM back and allows the turbine to generate heat in order to spool the turbo. And then it works, and then as the boost pressure starts to come up to the target, which you would set here under manifold pressure target, then what will happen is the timing will start to reduce out, and then obviously if it starts going over target, it will start applying fuel cuts to slow the turbine, cool the turbine down, and slow the turbo down. Then you've got ignition control timeout. So if the ignition control is active for more than 60 seconds, or the EGT is more than 1,000, then it turns the ignition retards off. Basically, that then stops things from getting too hot. Exit vehicle speed, self-explanatory. Once the vehicle speed is more than 64 kilometers an hour, basically it will exit the launch control. Ensure that that is quite high, that number, because obviously if it were to spin the tyre, you don't want the launch control to exit if you're using a hold timer. Exit pedal position, and these are all pretty self-explanatory. Then you've got a fuel cut ramp in rate. After the fuel cut is turned off, it allows it to ramp in every cycle of cylinder cycle. It will basically take out, say, 25% of the cut. Automatic re-enable of vehicle speed. So when the car was stopped less than 4 kilometers an hour, it will automatically re-enable the launch control strategy and to hold it there. You've got the option to turn off the secondary injectors if you want during launch. And then the exit timer is applied after the launch has exited. So after the hold timer is greater than the value you've set, or the launch control state is turned to off, then the exit timer can start. If you have got, say, a car which doesn't have vehicle speed, and you want to then be able to plot your nitrous duty or your wastegate pressure target in after the launch control for a drag car, you can do so. Drive-by-wire, you can limit the throttle position, which we've done on this particular car. So when the launch control is active, we can limit the throttle position to 50%. And the launch assist is a way that you can kick up the throttle position as well. But generally don't use that, just use the launch limit if you want to limit the drive-by-wire when in launch. So after the car has left the stage state, what then is used to control the RPM is the fuel cut severity, ignition cut severity, and ignition retard here. These values are a little bit less on the sensitivity-wise, because these are used once you're in a given gear and accelerating. Obviously, you've got the forces being applied to you from the gearboxes, obviously slowing the engine RPM down, instead of when you're revving in, like free revving the engine. So basically the torque reduction values generally have to be a bit less. So what have we got then? Base engine speed. So this basically is a way that allows you to then plot the RPM like a rev limiter, so to speak, based on time, so when you launch the car. So you can see here that I've got a target of 3,950 to hold the RPM at when it's on the line and stopped. And then when it launches, basically I actually drop the target. I bring the RPM down to allow the tyre to bite, and then try and maintain that RPM to basically maximize the acceleration. Now, this shape of ignition, engine speed limit doesn't always work for every car. Other cars you might need to basically bring up the RPM very quickly after you leave the line to spin the target to gain heat in that tyre to then gain acceleration. It depends on the tyre you're using. Every tyre has a different slip angle to gain the maximum acceleration. On a road tyre, around like 10% slip angle is a nice way of gaining the maximum acceleration. So this table you want to play with in order to basically get the best from the acceleration rate. So key thing now, if you have got it, a longitudinal G sensor fitted into the ECU, it's really useful that you're logging that, okay? If you don't have it, again, buy our 50 Hz GPS sensor. It has a 5-axis accelerometer built in, so you can plot long G, lat G, yaw, roll, pitch. Really useful when you're trying to set these cars up off the line. So what I'm going to do, I'm going to leave this launch RPM settings that are in here for the minute. Actually, what we're going to do, we're going to bring these down. So math subtract 400 RPM, just to show what the difference is or what can happen with when you change your launch RPM and what happens with a longitudinal G. So make sure you're in the right mode. So foot on the brake activates the launch control, and then basically you'd have to go on the accelerator, bring the RPM up. It will hold the target that it's wanting. If the limp switch comes on and it's not allowing you to basically enter launch mode from the transmission, then get some tools to look at the transmission to see what it's unhappy about, and then you can do so. Okay, so it basically brings the revs up, let go of the brake, and launch the car. So what we're going to look at, just from the feel then, where I'd lowered the launch RPM, the actual car bogged, and we had to plot that now when we look at the log. So let's have a look at the log. Device, read the data. Okay, launch 1. Let's just grab the data from the device. Don't worry about the rest. So delete the data that's on there. Okay, so let's have a look. So gauge X, let's now plot launch RPM, and then our actual RPM. And then our launch hold timer. Let's just split this into a different way. Okay, so you can see our launch hold timer here counting up as we launch the car. You can see our target is holding our target well, and on our launch RPM target here, you can see it drops down to 3.1. When it does that, the RPM obviously drops here to the torque control kicks in. If you look at your ignition retard values here, you can see the torque control has pulled the RPM down, and because it's then over the target here, so you can see the target for the RPM is 3,300, and you can see we're at 3,560. The RPM is over that. Then the torque control comes in. It then causes the RPM to come back under control, but at that point, the engine torque of the engine is not enough, and it's caused the engine to bog. And if you look at long G, like I explained, really important, you can actually see, look, the tyre gripped okay here off the line. It pulled the RPM down a little bit too much. It probably needs a little bit more on the RPM, like I said, on the line. You can see whereas the tyre is grabbing nicely, it's pulling the RPM down, the grip from the pulling the RPM down from the torque from the car is accelerating, and at this point then it bogs, and you can see the long G, the acceleration force really falls down, and obviously will affect our 60 foot or 0 to 60 time. So what we need to do is look at getting rid of this bog, getting the maximum from the longitudinal G off the line. So we need to hit it with a little bit more RPM. And then also basically have the RPM more flatter through here to stop it, so that if it does control the RPM, it brings it down. So what we're going to do, let's add basically 300 back into that. That will then give us a bit more torque off the line to basically exploit that. So again, find a safe place to do it. Okay, let's grab that log again. Again, just feeling it. It bogged off the line. So I'm going to grab the log. Launch 2 plus 300 RPM. Okay, let's load the latest data in SView. Look at the logs, same variables. So you can see that instantly allowing the tyre to having a bit more launch RPM off the line allows the tyre to grip a bit better off the line. Pulled but then 1.1 G, jumps up to 1.2, but again, as the tyre is starting to bite, basically the tyre bites, it pulls it down. The torque control maybe is a little bit too aggressive here in maintaining the RPM. I don't think so much it is so much the torque control. I think what it actually needs is just more RPM here to be able to actually hold the RPM flatter through here, because you can see our launch RPM is 3,600 and we're not actually near that. The tyre has actually gripped, pulled the RPM down to 3,400, and in which case it's already lost momentum. So what we want to try and do is actually hit it with more off the line, get it to basically hold that RPM flatter through here. I am going to drop the torque reduction amount a little bit here when it's over the error target here. So the target is 3,650, sorry, 3,610, and the RPM at this point here is 3.8. It does maybe potentially put a little bit too much torque out here to obviously cause the car to bite. So what we're going to do is we're going to do two things here. We're going to bump the launch RPM up in this area here. So look at the launch hold timer. So the hold timer are now 0.8. Below here, we're actually going to just keep that a bit, keep it still flat through there. But we're going to bump it up. We're going to add 200 RPM to it. And then what we're going to do is we're going to go into the ignition retard. And when it's over the target here, see here that it was getting up to 22, so it means that we're up here, the error. We're going to just drop these values down. So math multiply that. And take out, say, take out 15% of that, okay? So we've taken out some torque that it reduces when we're over the target there. Try and keep this RPM flatter through here to maintain the acceleration force, because we know our drive, we know our gear ratio, we know the RPM we need to be holding to maximize the acceleration. So we can basically try and get this RPM a bit flatter through here to get it launching better. So let's test that. Again, find a clear bit of road. Much better. Instantly I can feel the car. The amount of the G-force that it's pulling is so much stronger. So device, let's read that data. Okay, let's have a look. So now you can see the RPM is more flatter for it. It's holding the RPM target a little bit better. It needs probably a little bit more. That torque reduction probably needs to go. Difficult to say. Probably a little bit needs more torque reduction here in the lower error areas, because it's actually at this point here. You can see the timing comes in. It takes a little bit of time before that torque reduction will be applied. So it probably just needs a little bit more torque reduction here in the small error areas. So where we're targeting 3.8 and the RPM is at, say, 3.9, 100 RPM over, need to give it a little bit more torque reduction here. Here is decent now. You can see the launch RPM is holding flatter, and look at the difference in the longitudinal G. It's now basically peaking at 1.1, dropped a little bit here, where the tyre has obviously span a little. You can see the RPM has gone over the target, but if we basically, it's a reactive system, because obviously it needs to see the RPM change in order to get it. So if we can control this RPM a little bit better down here, this is going to help to maximize the tyre, stop this RPM flaring here. I'm going to put this torque control as the error starts to increase, like here. So launch it. So as we're in the region of, say, 200, 300 RPM, I'm pretty sure the timing reduction values I had in there before were decent enough. It's just where the tyre was grabbing before and pulling it down. So I'm going to put those torque control values back in, and then we should find that the longitudinal G will hold 1.3, 1.5 all the way. 1.3 is pretty much the limit of this tyre. So we can try and do that. So let's go into here. Let's undo. Press U to undo here. I am going to give it a little bit more torque reduction in this area here in the smaller error. And then, yeah, that is good. Okay, so all I've done now is I've just changed the torque reduction amounts. Haven't changed the launch RPM or anything like that. Don't believe that's needed. We've got the longitudinal G working quite nicely in that area. We just need to tidy up that first bit where the long G drops ever so slightly. So again, clear bit of road. Okay, let's grab that log. And you can see here now the torque hasn't dropped as much there. The torque controls hold the RPM a little bit more here. Again, probably could do with trying to get that RPM a little bit more under control here at this given point. So probably have a bit more torque control there. But you can see as it's holding the RPM nicely to match the launch RPM, it's basically accelerating really well. Yeah, much better that was. And then basically we can have a look, see what kind of you can see here why it would be not useful to use the vehicle speed, because you can see here as we launch the car, the front wheel is actually spinning. The front lifts because the engine's in the rear of this car. As the car launches, the front end lifts off the ground ever so slightly, unloads the front suspension, causes the front tyre to spin, and then that basically would ruin our whole launch control strategy if we were using that as the reference. So let's have a look what we've got anyway. The tyre does stabilise here. This is in kilometres, so let's just pick a point here. Say 100 here where it's finally stabilised. Press spacebar. Look at the point where we let go of the brake, which is here as the acceleration starts to raise and the tyre starts to spin. And our delta is 2.3, so it's accelerating pretty quick. 2.3 0 to 100 kilometers an hour is good in my books. Okay, hopefully this has been a good insight to help you get more from your launch control.